So everybody loved the first episode of the talk that I did with Wild Dog. He's an engine specialist that knows a lot about Unreal Engine, and we were discussing the issues that has been plaguing games with Unreal Engine. Now, Borderlands 4 is about to come out when I'm recording this, and so far I've heard nothing but problems with that game. And today's episode seems very fitting because one of the issues that I've heard with Borderlands 4 is the fact that it has forced ray tracing. And to me, forced ray tracing is one of the biggest issues that video games are having right now and what's causing really bad performance. Let's hear what an expert has to say about it. Okay, so now let's move on to the next topic since we've been talking so much about ray tracing. Let's discuss ray tracing versus backlighting. So,
Yeah.
in my opinion, I think a big chunk of what's been causing the problems with Unreal Engine 5 is ray tracing. And not only, to be fair, this isn't only a problem in Unreal Engine, it's also a problem in other engines. The ray tracing, like after the RTX thing came out, it's been a complete blessing for what I do because I do 3D animation and I do render a lot of things real time. It's very good for previs inside of Unreal Engine. But when it comes to video games, I think the amount of hardware that you need for ray tracing, not even path tracing, because path tracing is so insane, but for ray tracing, the amount of hardware that you need is so much, and the amount of detail that you get is so little, it's not even worth it. I think the way that Unreal 5 is geared, it's geared a lot towards lumen and ray tracing. To me, I think we overall, when it comes to video games, we need to go back to making light maps. It's easier than ever. All the tools that I use to create assets, whether it's environments, characters, weapons, anything, all have a way to do extra UV maps to encompass that light map if you want to make a light map. And also, like back in the day, Unreal Engine 4 had the RTX GI with the probes and everything. And I even did a video on that, and everything was running fantastic. And you had fantastic dynamic lighting. And when you bake lights, you can make the lights look as amazing as you want. And it's just a texture that's loaded into memory. You're not spending anything on real time hardware.
Yeah, no, I agree with this completely. So I think what happened here is you had the GPU manufacturers, looking into technology early on. I still remember the cusp of the next console generation with the Series X and the PS5. And I remember, NVIDIA was touting like, what they were going to be doing to kind of help with the overhead requirements. And DLSS was supposed to be part of that, right? So if you can cut back on the overall scene resolution of what you're having to trace against, obviously each ray is going to cost you a little less. I think what happened here is you kind of lost sight of the forest through the trees. People forgot that we were already on the cusp of moving from forward rendered engines into deferred rendered passes, where we were already shoving all of this light data. And, because dynamic lighting isn't new. We've had this for a while. We had it in Forward Plus and we had it in deferred rendering. So this massive G buffer spawns up into existence. It stores your depth data. It stores a bunch of different buffers. It handles post process. And one of the primary uses for the G buffer is it stores the lighting information so that you can kind of process it in the post. And each one of your shaders themselves in the base pass ends up being cheaper. Unfortunately, most people don't realize it introduces latency. In order for you to store that texture off in a buffer, look it back up and apply everything back in post, it's a latent pass. It's a two pass system. And that's the reason why a lot of people say you might not want to be using deferred in VR. Now, some games have done it. No Man's Sky's done it. I want to say that there's kind of a modified forward pass inside of Skyrim VR. The forest in Unity was a deferred rendered pass. But what ends up happening is you end up with this decade of GPUs that are like, whoa, your VRAM usage went from like half a gig to, 2 gigs to like 4, 8, 4, 6, 8, 12, 16 in a really quick hurry, right? It's no longer about how many CUDA cores does the freaking GPU have? How many shader compute units does this thing have? It's now a matter of like what is the bottleneck actually? And the bottleneck becomes the memory capacity of these cards, and not only the capacity, but the RHI DirectX 12's capacity to move that amount of data around at really fast speeds. So even the early 30 series cards in the late 20, like the 2080 Ti, they have ray tracing capabilities. They are DX12 cards, but I would call them DX12 ready cards. Their memory bandwidth is nowhere near what the late 30s 3000 series cards are the 4000 series cards. And like you mentioned, even if you upscale, and I hate that word. It's really downsampling. It's taking your native true resolution and downsampling it and then making it up in post, which again is another layer of latency. So when people are like, man, 30 frames per second doesn't feel like 30 frames anymore, or 60 frames per second doesn't feel like 60 frames anymore, there's some truth to that. That's because 30 frames and 60 frames in a deferred rendered pass with RTX will never feel like a forward pass base rendering on the rasterizer. It just won't. The fragment shader, the way all of that data is handled, it's pretty much chew on it and spit it to your screen in forward. It's chew on it, shove it into a texture, compress it, decompress it, do all the ray trace data, then shove it out to the screen, then slap post process over it, and then temporal sample everything for the cleanup pass. That's a mouthful of what's really happening here in your modern day renderer. So yeah, I think that Epic wanted to go this direction because for developers to be able to go to a studio head and tell them, hey, guess what? You're going to be able to make your game in half the time because you don't have to bake lights anymore. Not that that was a huge burden anyway. You know what studios used to do? They used to farm it out. They would hire some servers, some hosted servers up at AWS, and at the end of the night, before everybody clocked out and went home, push it up to the cloud and let it chew on it. We'll come back tomorrow and we'll see what it is. Now, iteration time sucks. But guess what we did back then? We would create a light test scene and we would bake it out per object. Now, Unreal Engine could have been better at this type of tooling. Everybody, if you go read the forums, they've been screaming that for the longest. Unity has this ability. Godot has this ability. Unreal Engine, nah, bro. If you want to use GPU Lightmass, you got to bake the whole freaking thing. So it's those kind of things where tooling was neglected on this older optimization method because they doubled down on Lumen and RTX being the path forward. And they were just like, everybody's going to buy new hardware and they'll be able to do it. But reality has shown us differently, you know?
Yeah. Yeah. And since you mentioned it, I fully agree because I do think the tools, I haven't tried Godot, but the tools within Unity to bake lights are more robust than anything that's in Unreal.
Yeah, dude, they have GPU Lightmass, like I guess you would call it Lightmass. They have GPU based compute for baking lights, and then whatever the GPU can't handle. Say you need specular directional, or you need normal baked into your scene, something that you need CPU access for to really be able to hit the shader pass that you need. And this was an early limitation of Unreal Engine as well, where certain shader computations couldn't be done in GPU Lightmass for stationary lights, point lights, etc. And that's where I think it's Lu Shang's GPU Lightmass extension came from, where a lot of people were unable to get the type of effects they needed out of GPU, like Unreal Engine's stock GPU Lightmass. And again, one of those developers that people love pointing the finger at filled a hole.
I came into Unreal Engine when it was Unreal Engine 4. So would you say this Lightmass was an issue from before Unreal Engine 4, like in UDK or UE3?
CPU Lightmass never was really an issue. Even in UE4 with GPU Lightmass was, highly experimental because it's so funny if people are familiar with the way that RTX was implemented. Early on, ray tracing was only available for RTX cards. Like the way that Epic implemented it, it was like you had to have an RTX card, and they used NVIDIA's direct technology for ray tracing. Then they decided, well, we're going to pull that out, we're going to deprecate it, and we're going to go with ray tracing that's compatible against any ray tracing capable card. And that's where, the modern UE5 pipeline stands. Um, but yeah, they had it in, they pulled it out, they put it back in later. And I can't remember right offhand if I think the 427.2 version of Unreal Engine has hardware ray tracing. Um, but it went through a deprecation period at 5.5.1. And there was some growing pains around the way that they ripped it out and put it back in. And I don't think the GPU light mass recovered. And that's essentially where Losheng's GPU light mass extension came from.
Yeah,
Um,
I remember the back in for the 27, which I think, am I mistaken? Was that the last iteration of Unreal Engine 4?
It was, yeah. 427.2 was the last binary cut, and then you essentially have 427 plus, which is, I guess if you were from the Unity camp, you would call it LTS. It's
Yeah.
pretty much where all the mobile developers and console people are dumping ongoing changes currently. Yeah.
Yeah, because I remember back then I was trying to use ray tracing to kind of like render my projects. I was even using, because I cannot use Unity for presentation shots. I was using Marmoset Toolbag and Keyshot, and I tried to use Unreal Engine with the ray tracing features, and it was not doing well. Like in 4.27, ray tracing, I think the ray tracing craze started back then, but it
Mhm.
was awful.
Yeah, yeah, it wasn't that great. You know, it technically didn't get good until the introduction of virtualized texturing, right? So
Yeah.
you have VSMs, you have virtualized texturing, and then you have virtualized light maps as well. That could be Atlas for high-end hardware. Um, but then again, like, none of those new methodologies work really well for mobile platforms. So it like, it was robbing from Peter to pay Paul. Like the engine started suffering for mid-range and lower-end hardware if that was the path he wanted to take. And then for anybody who was trying to fall back on older methodologies, like go back to DX11 for that stability, and then use SM5, well, you can't use virtual shadow maps. You got to use standard shadow maps, and then you got to kind of lean back on the heels of what came in the very tail end of Unreal Engine 4, which was distance fields. Like a lot of people don't know, but that's the optimal path for dynamic lit stuff. Like you get distance filled AO, you get distance filled baked lights for mobile, you get distance filled directional light shadows at like anything greater than say 10,000 meters. You can cut the dynamic casting shadow distance really, really close. And instead of doing like a stationary baked blend, you're blending between distance fields and your shadow maps, which is really performant and looks really good. This is probably something that's been mentioned in Thou Who Shall Not Be Named's video about
Yeah.
Days Gone, by the way.
Okay, so that was another clip from my talk with Wildlock Studios. There are more episodes coming out, so make sure you subscribe for that. I am, of course, going to be dissecting and looking at the models from Borderlands 4, so make sure you subscribe if you like that kind of content. Thank you so much for watching all the way to this point. Remember, leave a like, it really helps the channel. Remember to subscribe to Wild Dogs, visit his channel if you're interested in all these technical part of the game engines. And also remember, if you have any doubts, I know these are very technical talks, just leave your questions down below here on my channel, on Wildlock's channel, or in his Discord, wherever that we can help. Thank you so much for watching again, and I'll see you in the next one.